Subscribe to GovExec Plus on YouTube and stay informed on the latest in public sector news, insights, and thought leadership. Scan the QR code now or search for GovExec Plus on YouTube.
From the show floor at SOF Week 2026, where the future of special operations is being shaped in real time, this is GovExec TV. I'm your host, David Hutchins. In today's episode, AI at the Edge, Securing Decision Advantage in Contested Environments, we'll explore how AI at the Edge is transforming decision-making and enabling what defense leaders call decision advantage. We'll hear from experts at GDIT, Google Public Sector, and military leadership about how secure, deployable cloud capabilities tested in real-world exercises are bridging the power of AI closer to the mission. As operational environments become more complex and contested, the ability to process data, deploy AI, and deliver intelligence at the tactical edge is becoming mission critical. From denied communication environments to rapidly changing threats, commanders and operators need trusted technologies that work wherever the mission takes them. Today, we'll explore how government and industry are working together to deliver secure, resilient capabilities that enable faster decisions, improve situational awareness, and help maintain an operational advantage where it matters most. Now, let's meet our panel of experts here at SOF Week 2026. Today, I'm joined by Matt Osinski, AI and ML expert engineer at GDIT, Aaron Gussman, principal architect of national security at Google Public Sector, and Lieutenant Colonel Eric Sturzinger, director of research and engagements, artificial intelligence integration center. That's a mouthful, with the U.S. Army. Gentlemen, thank you for being here.
Thanks for having us.
Thank you.
Let's go ahead and dive right into the questions here. So, for years, Special Operations Forces have operated in austere, denied environments by necessity. But today, distributed and disaggregated operations are becoming standard across the Joint Force. Is the tactical edge now the operating model for everyone? And what does that mean for how we deliver secure AI and data capabilities forward? Eric, let's go ahead and start with you.
Thank you, David. So I would say it's moving in that direction, certainly, where soft forces were kind of the breaching element of that kind of shift towards the edge. It's definitely caught on with the joint services for sure in many different respects. I wouldn't quite make that extreme claim. There's still a role for the cloud, of course, right? In terms of scale and ubiquitous presence, availability, uptime, all those types of variables, performance metrics. But certainly the operations have, migrated towards the edge, and the need and necessity really to be able to have local computing resources that aren't completely completely dependent on, cloud network connectivity. Even edge-to-edge network connectivity can be contested in tactical environments, as we've seen recently in contemporary conflicts. But at least from the cloud-to-edge connection, that's probably the most vulnerable as we move more towards an edge paradigm, at least for priority high intensity operations.
Absolutely. Gentlemen, anything to add there on that question?
Yeah, exactly. What we're seeing with Google is a push towards an adaptive cloud, where you want to have the ability to bring your data and leverage like the larger cloud resources. It might be CONUS or OCONUS data centers when they're available, but you need that survivability in case you don't have that connectivity. Exactly.
Absolutely. All right, anything to add?
I mean, I think if we look at our soft community today, they've always rejected the one-size-fits-all mentality.
Absolutely.
They're looking for a converged network, infrastructure, storage, and AI platform that shrinks or expands to fit their mission use case. So I think when we talk about edge and AI, it's really focused on that decentralized decision-making pattern, leveraging technology to meet their mission focus.
Yeah, absolutely. So let's move on here. So as forces disperse and connectivity becomes less reliable, the operational environment grows more complex and less predictable. What are the most pressing mission challenges operators are facing at the tactical edge today? Who wants to jump on that one? Eric, let's go ahead and start with you as the tactical representative here.
Thank you. So I would say, at least from the Army perspective, but I think other services in the SOF community probably are experiencing this as well, is that with cloud, you can centralize a lot of resources and management, application development, and so forth, and oversight. With different edge nodes, it's a little bit more challenging, predominantly because different personnel, different units can be using systems in different ways, and maybe want to tailor the application and how they're using the data and using specific models. It can be unique, even between sister units. So it can be a little bit more challenging in having kind of a standardized architecture, like Matt said, trying to avoid the one-size-fits-all model. That can be more complex in how to manage and oversee that architecture, especially for the engineers and technical experts, maybe back in CONUS, to manage that system effectively.
Outstanding. Gentlemen, anything to add there?
I think what we've seen, with our partners like Google, is the ability, and like Eric mentioned, if you need more compute power, you need more storage power, you need more network. Today with Google, you can do it with click of a button in the cloud. It's a bit more difficult to do at the edge. In fact, maybe the only compute you have is the server that fits in your rucksack.
Right.
Being able to have the tactical discipline to right size your mission loadout, mission payload, while focusing more on the availability of power or network or comms and redundancy, requires tremendous amount of discipline to make sure that you have the right loadout for the right mission at the right time.
You mentioned the edge. So how does limited connectivity and contested space reshape decision-making at the edge?
I think from our perspective, being GDIT and what we see from our customers, is this natural tendency to operate in a decentralized fashion. So in cases where you have limited comms to no comms at all, it really redefines how we architect and solve some of the traditional data problems that we see being at the edge. Kind of the one example I always like to give is, when we're integrating with counter UAS sensors, as an example. To our customers, latency is the lifeblood. They don't want to wait 1 or 2 or 3 seconds to identify.
Or too long, yeah.
Yeah, what am I looking at? Is it a threat or is it not a threat? And having the ability to perform all of that analytics and decision-making power at the edge to spit out that prediction and classification within milliseconds is really the meaning of life and death for a lot of use cases over here.
Absolutely. Anything to add there?
Yeah, and I think all of us are in the early stages of adopting LLMs as a technology and really fully understanding what they can do. And we're still in the early stages of figuring out what's the most efficient way to bring the power of an LLM to the edge. We've had some great successes in some of the work that we've done already, but I think over the next couple of years, we're going to really build out our internal pipelines to be able to deliver customized LLMs to those edge environments to sort of customize the rucksack, as you were saying before.
Outstanding. Then, so let's stick with the tactical edge. Let's talk about AI a little bit. Where does AI genuinely make a measurable difference at the tactical edge, and where is it still evolving? You can go ahead.
I'm happy to take that on.
Sure.
It's an exciting environment for us. Our customers are always looking for this personalized experience, and if you look at AI in the past 10 years, it's been really good at identifying kind of the key features for every single particular customer in their mission set. And what we're seeing now, especially with Google's distributed cloud appliance and the ability to bring a large language model to the edge, you're able to tailor the software experience to each individual user. And we've never seen that before. And really the benefit of it here is the ability to have exactly the data when you need it, in the format you need it, without requiring a lot of initial development pipelines. So it's really bringing velocity directly to the user at the edge.
Sounds very helpful.
Yeah, the thing I would add to that is the power of LLMs a lot of times lies in their emergent behaviors, things that they weren't necessarily trained on, which makes them very adaptable to new situations or dynamic situations or evolving situations. So there's a lot of power in being able to analyze new types of data that you might not have seen before, or new scenarios that you're encountering, or look for something unique in imagery that a model wasn't necessarily trained on. And you absolutely want to have the most performant models that you can available in those environments.
Eric, anything to add from your perspective on the topic of AI and that tactical edge?
Sure. On the application domain side, I would say that, we've all heard a lot of the different computer vision applications that have been deployed out for quite a few years now, and the services in the SOF community, of course, at the edge, that have provided a lot of capabilities for warfighters. On the language model side, that's relatively new, only in the past few years, and that is starting to become quite a powerful complementary capability to the traditional, computer vision models that are definitely still in use. We might see those surpass even the capability and power of computer vision models in terms of the overall aggregate value that they provide to warfighters, both in the planning side and the execution side, because we know there's a lot of different efforts ongoing in the department with using language models for MDMP, IPOE, and different planning tasks prior to the mission, not just during the mission to analyze some action or activity by the enemy, for example.
All right, well, I want to stick with AI, but let's talk about securing the AI a little bit, or making things secure at the edge. So how do you ensure AI-enabled capabilities at the edge remain secure, reliable, and mission assured in denied environments? This is very important for the future.
I can go ahead
Aaron,
and start with that. So at least in the case of Google's distributed cloud air-gapped appliance, there's a number of things that we're bringing to bear. But like sort of chief amongst them is, even though it is sort of this disconnected, self-contained compute environment, you apply all the same security precautions that you would as if it was public on the internet, right? Exposed to the broader internet. You don't take anything for granted. So primarily that's encryption. So we're encrypting everything in transit and at rest, and all the hard drives are keyed. So if you pull the keys, then that data is effectively dead. So that's a key tenet of it. Another one would be the permissioning system, the ACLing system. You don't want default roles that are over permissioned, right? Like you want to be very deliberate in who has access to which underlying APIs or capabilities of the system, and you really want to fine tune those permissions.
Outstanding. Are you anything to add from your perspective?
So to add on to like physical network encryption, security, and that sort of thing, we also have to think about the adversarial aspect. A sophisticated adversary who, itself has AI ML capabilities and, develop a lot of the same types of models and employ them, vision, language models, and so forth as we do. Perhaps not to the same level of sophistication, but possibly. We have to think that they will try to do their best to attempt to avoid our models being operationally effective. And they can do that through various means, whether it's, modifying their appearance, their behavior, their tactics, techniques, and procedures. They can take all these different approaches from an adversarial perspective to try to defeat our models. And if we've invested a lot of money, a lot of time and effort, a lot of technical effort goes into developing these capabilities over time, then that could render some of that research and development, not necessarily moot, but almost like a compromise, if you will, because they have taken some easy, relatively simple, non-complex action to render the model not obsolete completely, but certainly less operationally effective.
Okay. And let me ask, as AI-enabled edge computing moves from experimentation to operational reality, what have recent exercises validated, and how do we translate those insights into expertise-scale deployment across the joint and allied forces, from architecture and acquisition to workforce and culture? Sorry, that's a long question, but does anyone want to jump on that one?
Yeah, I can take a stab at it.
Thank you.
What we see from exercises is essentially our customers are bringing a stopwatch and saying the moment you arrive on site, you survey the area, how quickly can you get your capability up and running? And typically under 30 minutes or less. We look at kind of this whole entire ecosystem from a truly end-to-end perspective, and we're not looking at solely bringing hardware that's ready to ship and ready to connect in the sense that, hey, if I plug it into my communications network, or I plug into a generator, does everything pop up? We're looking at it from a more holistic perspective. So with the GDC appliance, as an example, that coming with a provisional ATO makes it very easy to go to an authorizing official and say, hey, can I jump on your IL6 network? Not in 7 to 8 months, but in literally 7 to 8 minutes.
Speed is important.
Speed is very important in this stage.
The other thing that we've found incredibly valuable is like with training exercises with our partners with GDIT and getting feedback from actual users in the field. Like that's so valuable. Like there's no substitute for that. And it's really important from like a product development standpoint and a technology development standpoint to understand what are the strengths and what are the gaps that we need to address. But it's also really inspiring too, when you get to tell those stories of like, oh, we were in the field and so did this and we never thought that they would. And that gets the whole team really excited as well.
Absolutely. Can I get the warfighter's perspective on that as well?
Sure. So, just to piggyback on that, sometimes operational demands and requirements aren't necessarily perfectly aligned with what existing technical capability has already been developed, whether it's from never. Maybe that's Captain Obvious, but that's kind of the point where you got to try to make those two converge. And I think the goal is to try to converge those in as short amount of time as possible with iterative experimentation in the field, with developers and warfighters talking hopefully the same language to a certain extent, and being able to agree on something and say, okay, this is what I want, and they can convert that with technical development to converge to that operational requirement as best as possible.
Outstanding. Then let's shift gears a little bit to talk about some predictive analytics. So the difference between reactive and predictive operations can mean decisive advantage. How does predictive analytics shift forces from responding to events to anticipating them? Who would like to take that one?
I'll give you a great example that we saw back in Guam this past summer. A lot of the power was provided by generators. And with generators, you have to constantly keep them refueled. And it'll be helpful to know when you have to schedule the next delivery of fuel.
Right.
Through the use of AI large language models, we essentially ingested a 300-page manual of everything soup to nuts on how to operate this generator. And we had folks go out to that generator with their camera and on their phone, take a snapshot of the generator panel. And we asked the large language model, hey, given all the information that you have based off of the manual data and the current operating environment, can you help us predict when the next time we'll run out of fuel so that we could get ahead and be a bit more predictive as well as proactive in keeping the lights on? And it was a relatively simple use case, but a very powerful use case, because if that generator does go down, or if we lose even a minute of downtime, there's so many systems and comms gear that are dependent on that. And the fact that we're able to execute this use case literally under 5 minutes kind of goes to the whole velocity aspect, as well as having that operational benefit all packaged together in one solution.
Yeah, absolutely. I wouldn't want to read the full manual.
Who knows?
Aaron, you had something to add there.
Oh, well, I was going to point out, I thought Eric gave a really great example earlier, which is, I think LLMs really excel at predictive scenario development. They're actually surprisingly creative. And so if you do need to sort of craft what if, or you almost need like a brainstorming partner, they can be really helpful for that. Or even, co-working with like an analyst, they can add some additional rigor there, right? Like you can submit your analytical judgments to it, and it can kind of ask hypotheticals, right? Or look for gaps in your logic, or if appropriately sourced with reference material, come up with alternative hypotheses.
Interesting. Eric, anything to add on that?
Yeah, with respect to, reactive to predictive, that leap, it's not only in analytics, it's also for autonomous systems, and that we should try to progress towards not just having a drone or ground vehicle or whatever enabled systems out there operating to react to the environment. They detect some patterns of pixels and they report it to a human somewhere for some decision. Ultimately, we want them to be able to predict based on previous training data and behavior and operational data of some type, to predict to a certain extent what a enemy or group of enemy platforms of some type will do in this particular situation, given the terrain, the mission, the task, the enemy sit temp, situational template, and all this other information. We do want them at some point to be kind of like us, and we can kind of predict based on our own tactical or operational experience what we think the enemy is probably going to do here. We ultimately want autonomous systems to start to be able to do that to one, maximize their own survivability, and two, complete their mission, whatever that may be.
Absolutely. I'm glad you brought up autonomous systems. There's quite a few on display today, even right behind us. They're zooming around, so a lot of practical application taking place. Let me ask, so what impact does locally processed AI-enabled insights have on operational tempo and decision cycles? Anyone want to take that on, that kind of additional question to one we have?
Oh, I mean, there's the obvious example, right, of instead of bringing your data back to the compute, especially if that's somewhere in the United States, bringing your compute to the data is going to shorten that. It's going to be a little bit quicker, and the added benefit of that resilience as well.
All right. Just a couple questions left for you, gentlemen. So as connectivity becomes contested or unavailable, how does AI at the edge enable forces to operate with greater autonomy and confidence? Anyone want to jump on that?
Yeah, absolutely. That's one of my passions, in the sense that, comms are essentially the lifeblood of how we move data, how we communicate. No environment is ever going to be perfect. And typically what we see at the edge is bursts where we're able to send multiple streams of video 1 minute, but then the next minute, suddenly the network goes down.
Right.
We view it as the fact that your underlying network has to be adaptive to the mission use case, but also what resources you have available at your disposal. There's a lot of AI being embedded in how networks reconfigure themselves, not only to take advantage of essentially what your first mile path out is, whether you're using LEO or GEO satellites or commercial cellular networks as well too, or even local fiber networks to get the data out. But on the flip side, we're also seeing AI help save power and help operate more efficiently. So during times when you don't have congestion, hey, why don't we turn back down, save some of that precious fuel that we talked about earlier, and operate more in a self-contained, a more aware manner.
Excellent. Anything to add, gentlemen?
Yeah, I would add, it increases risk for a commander to have any level of dependency at the edge in contested environments on any amount of network connection, whether it's back to the cloud in CONUS, whether it's to, tactical operational headquarters, a few hundred kilometers away, whatever it may be. Any amount of dependency increases the risk for a commander to complete a mission, only insofar as there's some reach back I need, even if it's not very far away logically or physically. There's still that risk, and if we can process as much as possible locally, assuming that capability, even if it's exquisite and brand new and state of the art, as long as we have the computing capability and the manpower to operate it, troubleshoot it if necessary at the edge where the warfighters are physically, then that reduces a whole lot of risk. So it's really kind of a risk trade-off in terms of how state of the art, how advanced capabilities you want at the edge versus how much dependency you think you'll be able to remove back to the cloud or even local tactical networks.
And I suspect where we're headed is it's not going to be like a binary thing. It's going to be a sort of an adaptive sliding scale where we'll continually improve the models that can be pushed to the edge. And so the amount of computing that you can do at the edge is going to continue to increase. But you'll still always want to maximize the utility of any connectivity that you do have while you have it and send as much data back as you can for whatever type of additional analysis that you can leveraging the entire compute power of a full cloud.
Outstanding. So across diverse federal missions, where are we seeing tangible improvements in decision speed, operational effectiveness, or mission assurance because of edge AI?
Well, it's certainly reducing the cognitive burden. Sounds helpful. If you look back 10 years ago, the amount of data that's being processed or sent over networks compared to today, it's going to look like absolutely nothing. Data usage has been growing exponentially, and really we see the convergence of kind of the IT piece, the AI, and the sensor and data collection algorithms, basically all coming together to identify, not just essentially sensors producing data, but what are my key entities, and are those entities important to me? For instance, our customers want to prioritize non-cooperative aircraft versus cooperative aircraft, as an example. And really, without kind of this convergence, traditionally, there'd be no way to do this at scale without having those key enablers at the edge.
Sure. Anything else to add?
The thing I would add is what's really exciting to me is that it feels very much like we're just in the early stages of all of this. Like on near weekly or monthly basis in my own personal life or professional life, I'm adopting some new AI technology, and it doesn't feel like the pace of that is even slowed down remotely.
Not remotely,
which can be a little daunting at times, but you know, and that's just going to continue to move closer to the field, and that's going to continue to change, I suspect, very dramatically over the next probably 2 to 3 years.
Eric, anything?
And to Andrew's point, maybe we're at the bottom of the S-curve in terms of AI adoption, right? Like we can't really predict, is this rate going to stay the same? Is it going to slow down, or is it going to speed up? More than likely, it's going to speed up, perhaps only out of operational necessity, in that we've seen certain tools, certain application domains, vision, language models at this point, and maybe there's a next paradigm that's going to really transform warfare even more, especially with our rapid adoption and aggressive research and development efforts, and especially the operational experimentation efforts that we continue to see. We might be at the bottom of the S-curve in that you might see 5 to 10 years, rapid, even a greater rate of development across a large set of AI-enabled systems across different application domains.
All right. Gentlemen, I have one last question for you. So we're looking towards the future now. So what technologies or capabilities are most critical to accelerating the tactical edge, cloud, and AI adoption over the next 3 to 5 years? Anyone want to jump on that?
I have my own thoughts. Let's see what
Please.
Well, why don't I start then?
Yeah, sure.
I think from a network perspective, zero trust network in terms of applying it to the tactical edge in some form or fashion, making it linked or making it kind of making a comprehensive zero trust network, cloud and edge combined, so that they're replicated or a sense connected. A lot of times, you know, we have kind of separate network and data structures for the tactical edge versus the cloud and enterprise. We want to kind of converge those so that the same policies apply all the way upstream and downstream. Although there may be slightly different policies at certain echelons, we still need to make it a converged network, converged data fabric. But I would also say that if you do that, then it enables the data to flow freely down, up, wherever it needs to be, like Andrew said before. And so that way, if you need to transport models that are only housed or stored in enterprise, can get pushed to tactical units or warfighters, right, in a kind of a shorter time span. But as well, you can transfer the data where you maybe need to have a different data set or sub data sets so that you can fine tune, retrain models at a certain physical or logical location.
Yep. Yeah, absolutely. There's this proliferation of data availability, new types of data from new sensors as well. It's going to unlock a lot of value from large language models. What really excites me, though, is the work that's going into, there's sort of two things happening simultaneously, right? So one is Google and the other foundational model builders are building these like massive models on fairly 6 month to a year release schedules. And with each new generation, we're expanding the capability of those. But those models tend to be, they're very large and for the most part, and they require a lot of computational resources to run at scale. What doesn't get quite as much attention is the work that gets done to distill those models down into smaller models that are just as functional or share most of the functionality, I should say, but can run on a much smaller computational footprint. And we're getting a lot better at that. And so as our ability to improve like the distillation techniques and the ability to sort of shrink down these models so that they can run on smaller devices, like phones or edge devices, that's going to bring a lot more power into the field, which combined with additional data is really going to unlock a lot of use cases that we haven't even thought of.
Yeah, I think to round it out, reusability is often a key theme at the edge. Obviously, you may only have one server rack there that has to be used across multiple coalition partners. So at that point, zero trust is extremely important for the data segmentation piece. And then not only the hardware usability, but if you're able to reuse the large language models that Google is producing out there, it suddenly becomes a force enabler. I've seen this in person. You have folks from Japan, the British Royal Air Force, the Australians, all in the same room, translating and retranslating weather reports on the same piece of equipment using the same machine. So imagine from a coalition perspective, the benefits you get there.
Yeah, incredible. Well, gentlemen, with the last couple minutes that we had, is there anything that we didn't cover that you'd like to add the discussion? Eric, yes, please.
Yeah, if we think about the sheer diversity in the number of tasks that soldiers perform in tactical and operational environments, as large language models start to at least assist soldiers in accomplishing those tasks, we have to think about language models have been fine-tuned and kind of specialized into performing very specific tasks. You know, one language model doesn't answer every query in the world, of course. So generally, a query gets routed to a very specific language model so that a model that's been trained on very specific data sets can answer it with the greatest amount of accuracy as possible. And when we think about all those tasks, we want the best model to perform that particular task that is available at the time. And being able to do that under DDoS conditions when the network topology may change, nodes may be defeated, destroyed, and so forth, we need to ensure that, just like with exclusively human army, where we don't have all this computing capability and AI capability, we're able to rapidly respond and adjust and be adaptive in that environment where the enemy may target specific computing nodes to prevent our ability to perform MDMP or intelligence preparation of the operational environment or whatever other critical tasks that a tactical unit may want to execute.
Mm-hmm. Yeah, within Google, there's a lot of research that's being done to support both commercial and enterprise and government customers to that is transferable, but we're not quite there yet, especially on the detail aspect. So there's a lot of work that's being done to given a prompt or a use case or a query of some sort, which LLM should I route it to? What's the most efficient way to get the best possible answer? So there's a lot of internal research going on there. And similarly, with the current crop of large language models, they can do tool use, they're agentic, they can call these external agents. And so there's a lot of research in how do you choose the right agent given the query, or if you have multiple different agents that are slightly different from each other, how do you do that? But I think there's still a lot of work to go to bring that additional DDIL aspect to it, right? Especially when you might not always have access to the same agents or capabilities.
Right. Matt, anything to add?
Yeah, absolutely. As we consider these next generation architectures, one of the key foundational questions our customers always have is, can we actually deploy this on our equipment, right? Because we have fixed constraints, fixed resources. So we're even using large language models to understand the current performance of the usage of whatever services are currently running the equipment, and really understanding if we have the space in terms of the network, the computational power, the storage to physically put these in, or should we slim down and go to a smaller large language model, as an example?
Absolutely. Well, thank you, gentlemen. That's all the time we have. I really appreciate you being here and providing your insights for this very engaging discussion. I know I learned a lot, and I'm sure our audience did too. And thank you to everyone watching. We also want to thank GDIT and Google Public Sector for underwriting today's discussion. From SOF Week 2026, this is GovExec TV. I'm David Hutchins. Thank you for watching.